So here's another example of a scatter plot. This is exploring the correlation between the kilometers traveled by 2012 Toyota Corollas and the price of a bunch of 2012 Toyota Corollas. So let's have a look at the different things we talk about. First, direction. So you might have been able to recall that when we're talking about the direction, we're talking about kind of the overall trend or direction of the scatter plot. So it could be positive, it could be negative, or no association. So if it's positive, as our explanatory variable increases, and remember our explanatory variable, we always plot on the bottom, just like in science, we plot the independent variable along the bottom, and then we plot our response variable along the y-axis up here. So if we had a positive direction, as our response variable increased, as our explanatory variable increased, so too would our response variable. But that's not what we have here. We can actually read on our scatter plot really visually that as we progress further right on the graph, as our explanatory variable increases, our response variable is actually decreasing. So we have that inverse relationship. We can really see that negative pattern just quite visually on our graph. So direction is the first thing we discuss. And then also form. So form being like linear or non-linear. This one, I would say it looks pretty linear to me. Next thing is strength. Is it strong? Is it moderate? Is it weak? Well, for this particular scatter plot, the dots are like fairly closely clustered together, so I'd probably guess somewhere between like moderate to strong. Like it's seeming like a pretty well-established relationship. Like the dots just aren't randomly scattered around. And then the last thing is outliers, which I wouldn't say we really have any significant outliers here. They're all kind of fitting our trend or pattern pretty well. So to kind of pause there for a second and make some links to our other content. For all of these, I've just assumed, I've guessed that it's linear. I've assumed that it's negative, and I've kind of vaguely guessed that it's strong and moderate. But what I kind of want to challenge you to think about is there more precise mathematical ways that we could kind of discern each of these? And yes, there is. So it might have potentially come to mind with the direction when we calculate an R value. An R value, a Pearson's correlation coefficient, is actually positive or negative, and the sign actually tells us about the direction. So this, for example, because it does appear to be quite negative, I would assume that it's going to have a negative R value, and that could actually confirm for me that it is a negative relationship. Or to link this in with a least squares regression line, if it has a negative slope or a negative gradient, which this definitely indeed would if we were to add a least squares regression line, the signs, whether it's positive or negative, of the slope would also tell us that information. And what about the form? I've just assumed this is a linear relationship, but if I wanted to test that mathematically, I'd have to calculate, you might have guessed it, a residual plot. Because remember, our residual plots test the assumption of linearity. So at the moment, I've just assumed it. But if I want to prove it, I would need to construct a residual plot. And then when it comes to the strength, we touched on it briefly before. Again, that's our R value, our Pearson's correlation coefficient. Whereas here, I'm just saying like, oh, maybe it's like moderate to strong. If I calculate a Pearson's correlation coefficient, I can determine exactly mathematically and precisely what is the strength of this relationship. And again, R value is only appropriate if it is linear data, and because this does appear linear, I would definitely be able to calculate a Pearson's correlation coefficient. Well, only definitely if I'd first also constructed a residual plot to prove that it was linear, and then I would be able to calculate my R value to kind of determine that mathematical strength. So there.